Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. So in this particular video, I will be teaching the exercise part which is there in atoms and molecules chapter, which is the third chapter in 9th standard science subject. So in my previous 4 videos, I have explained atoms and molecules chapter completely. So you can refer those 4 videos and understand the concepts which are there in this particular chapter, and then solving the exercise questions will be easy. Coming to the first question in this particular exercise, here they are telling there is a compound of boron and oxygen. So boron and oxygen are forming a particular compound, and in this particular compound there is certain amount of boron present and there is certain amount of oxygen present. So the total mass of this particular compound which is made of boron and oxygen is 0.24 grams. So out of 0.24 grams of the mass of this particular compound, boron is having 0.096 gram mass. So this is the mass of boron. Oxygen in this particular compound is 0.144 gram. So based on this particular data, you have to find out the percentage of composition of these elements which are there in this compound by taking the total weight of this particular compound. Here the reactants are boron and oxygen. So the weight of boron is 0.096 gram and the weight of oxygen is 0.144 gram. And the total weight of this particular compound is 0.24 gram. So now, according to law of conservation of mass, the reactant weight should be equivalent to the product's weight because mass is always conserved. So now the product compound has boron and oxygen in it. So in this particular compound, the weight of boron is 0.096 grams and the weight of oxygen is 0.144 gram. So now if you add these two weight, you will get the total weight of this particular compound. You can try that. 6 plus 4 is 10, 1 carry. So 9 plus 1 is 10, 10 plus 4 is 14. So 4, 1 carry. So 1 plus 1 will be 2. So you can clearly see here, law of conservation of mass is actually obeyed in this particular case. But in this question, they have asked the percentage of composition based on weight. So percentage of boron can be calculated as 0.096 gram of boron in 0.24 gram of compound, and multiplying this with 100, you will get the percentage of boron by weight. So now you can actually multiply this both numerator and denominator with 1000. So when you do that, you will get 96 on the numerator and 240 in the denominator. Now here 24 into 10 will be 240, 24 into 4 will be 96 into 100. So here 10 ones are 10. So 4 cannot go with 10, so we can take 1 point so that it becomes 40. So 10 fours are 40. So 0.4 will be your answer. So 0.4 into 100 will be there. So what is 0.4 into 100? That is 40 percentage, because here we are converting this into percentage, you have to put percentage symbol. So percentage of boron by weight in this particular compound is 40%. So if boron weight is 40%, then obviously oxygen weight should be 60%, because we have added up here has given us the answer 0.24 gram, which is matching with the weight which they have given for this compound. So that shows remaining percentage should be oxygen. Anyway, we will cross check that. So here we have 0.144 gram as the weight of oxygen divided by total weight of compound is 0.24 gram. So this is percentage of oxygen by weight. So into 100. So here we are multiplying this with 100 to convert this value into percentage. So now you can again multiply this with 100 or 1000. So it will be 144 divided by 240. So now again if you do calculations, you will get 0.6 as your answer. So when you calculate this, you will get 0.6 as your answer. So 0.6 into 100 percentage will be 60 percentage. So 60% is the answer for percentage of oxygen present by weight in this particular compound. Coming to the second question in this particular exercise, here they have given 3 gram of carbon is reacting with 8 gram of oxygen to produce 11 gram of carbon dioxide. So here they are giving definite proportion of carbon and oxygen to form carbon dioxide. So now here we have carbon dioxide as our compound. You can clearly see carbon dioxide have one carbon atom and two oxygen atoms. So what is the atomic mass of carbon? Atomic mass of carbon is 12 and the atomic mass of oxygen is two oxygen atoms are there. So 16 plus 16 will be there. So that is 32. So 12:32 is the ratio of carbon and oxygen in this particular carbon dioxide molecule. So what is 12:32? 12:32 is 3:8 ratio. So that means always in carbon dioxide there will be 3:8 ratio, mass ratio of carbon and oxygen will be there. So this is actually the mass ratio of carbon is to oxygen. So if 3 grams of carbon is there, then 8 grams of oxygen should be there to form 11 grams of carbon dioxide. So that means here they have given perfect mass ratio of carbon and oxygen. So here in the question also they are giving 3 gram of carbon is reacting with 8 gram of oxygen to form 11 gram of carbon dioxide. Now when we calculated mass ratio of carbon and oxygen in carbon dioxide, that is actually 12:32 or 12:32 can be written as 3:8. That means 3 gram of carbon should be there with 8 gram of oxygen. Then only there will be a stable carbon dioxide formation. And this particular mass ratio should be maintained throughout the carbon dioxide compound. So this law is governed by law of definite proportion, because in this particular question they have asked which law is applied in this particular question. So the law which is applied here is law of definite proportions. So now I have explained in brief what is law of definite proportions. So if you want detailed explanation of law of definite proportions, then refer my previous videos where I have explained different concepts which are there in this particular chapter. 3 gram of carbon is actually reacting with 8 gram of oxygen. So only when this particular ratio is maintained, there will be formation of carbon dioxide. So now in this question, they have asked if 3 gram of carbon is reacting with 8 gram of oxygen, then if the same 3 gram of carbon is reacted with 50 gram of oxygen, then how much amount of carbon dioxide will be present? So in this case also, 11 gram of carbon dioxide will only be remaining. So where will the other oxygen go? So here, other oxygen molecules which are there will go unreacted. That means 42 gram of oxygen will be unreacted. 8 gram of oxygen out of 50 gram of oxygen will be reacting with 3 gram of carbon to produce 11 gram of carbon dioxide. Because according to law of definite proportions, if you want all 50 gram of oxygen to react with carbon, then that much amount of carbon should be there. But here they are not giving more amount of carbon, they are giving just 3 gram of carbon, and 3 gram of carbon can only react with 8 gram of oxygen to form 11 gram of carbon dioxide according to law of definite proportions. Because same amount of mass ratio should be maintained to form carbon dioxide compound, that is 3:8 ratio of carbon and oxygen. So to maintain that particular ratio, here 3 gram of carbon will react only with 8 gram of oxygen. It will not react with more oxygen which is present in 50 gram of oxygen. So remaining 42 gram of oxygen will remain as it is. They don't involve in the reaction. Only 8 gram of oxygen will involve in the reaction with carbon to produce 11 gram of carbon dioxide. This law is governed by law of definite proportions. Coming to the third question, here they have asked what do you mean by polyatomic ions. So what do you mean by ions? So before going into polyatomic ions, what do you mean by ions? If you want definition for ions, if you want explanation for ions, again you can refer my previous videos for the concepts. Here I will just brief out what are ions. So ions are chemical species which has charge on it. either it might be positive charge or negative charge. Based on positive and negative charge, they are known as anion or cation. So here negative ions are known as anions and positive ions are known as cations. So these things you can recall. So ions are basically charge species. So for example, if you take Cl minus or H plus, so these are all are examples for ions. But now here they have specifically asked what do you mean by polyatomic ions. So ions which has two or more atoms involved in that particular ion formation, so that particular ions are known as polyatomic ions. For example, if you take OH minus, so OH minus is an ion because it has net negative charge on it, because here the compound is not stable. That is, if you take H2O, that is water, here the net charge of H2O will be 0 because OH minus will be having negative charge and H plus will be having positive charge. So this particular H plus and this particular OH minus react with each other so that this particular negative charge and positive charge are satisfied with each other, so that the net charge of that particular molecule will be 0. But if you just consider OH minus as your example, then this particular OH will have negative charge with it. Hence OH minus can be known as an ion. But in this particular ion, you can clearly see two atoms are involved, that is oxygen and hydrogen. But in case of Cl minus, there is only one atom, and even in the case of H plus, there is only one atom. So this cannot be polyatomic ions, this can be a monoatomic ion. But here two atoms are involved, so this can be known as polyatomic ion. Even HSO4 minus, so here this is also an ion because this HSO4 has negative charge on it. So this can also be known as an ion because this chemical species also have charge on it. So this HSO4 minus contains hydrogen, sulfur and oxygen are involved in this particular ion. So that's why this ion is also an example for polyatomic ion. So OH minus can be the example for polyatomic ions, and even HSO4 minus is an example for polyatomic ions. Here H plus is not an example, Cl minus is also not an example. So this is what polyatomic ions means, and these are the examples for polyatomic ions. Coming to the fourth question, here they have asked to write the chemical formula of the following molecules which they have given in this particular fourth question. So coming to the first question, that is A question in this particular fourth question, there they have given magnesium chloride. So in magnesium chloride we have Mg and chlorine. We know that the charge of Mg ions is 2 plus and charge of chlorine ions is Cl minus. To satisfy two positive charge of magnesium, one negative charge is not enough of one chlorine, so there should be another chlorine present. So two Cl minus ions can react with one Mg2 plus ion to form MgCl, and we are actually using two chlorine atoms, so it will be Cl2. So MgCl2 will be the chemical formula for magnesium chloride. Similarly, coming to the B question in this particular fourth question, here you have calcium oxide. So in calcium oxide, calcium has two positive charges and oxygen has two negative charges. The charges are balanced and hence the net charge of this particular compound will be 0. So CaO is the chemical formula for calcium oxide, and always while writing chemical formula, metal should be written first and then non-metal should be written second. So here calcium is a metal and oxygen is non-metal. So you should write calcium first and then oxygen. You cannot write OCA. This is wrong because you should always write metal in the beginning and then non-metal should be written while writing chemical formula of different compounds. So coming to the C question in this particular fourth question, here they have given copper nitrate. So what is the chemical formula for copper nitrate? So here the charge of copper is 2 plus and nitrate means it is NO3 which has charge minus. So here two NO3 ions will be reacting with one Cu2 plus ion to form copper nitrate compound. Cu will be written first because copper is a metal, and then NO3 will be written, but here you are using two NO3 ions, So NO3, you should put bracket for this NO3 because NO3 contains two atoms in it, that is nitrogen and oxygen. So you should put bracket, and outside bracket in subscript you should write 2. So here this particular 2 is applied for both nitrogen and all three oxygen atoms which are present with this particular nitrogen. So CuNO3 twice. So this 2 should be written after the bracket. So that bracket should be put for this NO3. So the chemical formula of copper nitrate is CuNO3 twice. So coming to the D question in this particular fourth question, there they have given aluminium chloride. So the charge of aluminium is 3 plus, that is Al3 plus, and charge of chlorine is minus. So here 3 chlorine atoms are required to balance 3 plus charge of this particular aluminium. So one atom of aluminium will be reacting with 3 atoms of chlorine, that is AlCl3. So AlCl3 is the chemical formula for aluminium chloride. So coming to the E question in this particular fourth question, there they have given calcium carbonate. So calcium carbonate, in calcium carbonate you have calcium and carbonate, that is CO3 minus 2 minus. So CO3 has 2 minus charge and Ca has 2 plus charge. So here easily one Ca2 plus can react with one CO3 2 minus, so that this 2 plus and 2 minus charge can be satisfied. So CaCO3 will be the chemical formula for calcium carbonate, because here both calcium and carbonate has 2 plus and 2 minus. So same magnitude of charge is there, opposite charges are there. So that can be cancelled with each other and CaCO3 can be written. So CaCO3 is the chemical formula for calcium carbonate. Coming to the fifth question in this particular exercise, here you have to write the elements present in the compounds which they have given in this particular fifth question. So coming to the first question in this particular fifth question, that is A question, here they have given quicklime. So what do you mean by quicklime? Quicklime is nothing but calcium oxide. So calcium oxide is known as quicklime. So as the name represents, in this calcium oxide there will be calcium atom and oxygen atom. The chemical formula of calcium oxide is CaO. So in CaO you have calcium. So calcium is one particular element and oxygen is another element. So calcium and oxygen are answers for this particular A question in fifth question. Coming to the B question, here they have given hydrogen bromide. So in hydrogen bromide, so if you write the chemical formula of this particular hydrogen bromide, it is HBr. So here clearly you can notice that hydrogen is there in this particular HBr and also bromine is there in this particular HBr. So hydrogen and bromine are the elements which are there in this particular hydrogen bromide. Coming to the C question in this particular fifth question, there they have given baking powder. So baking powder is also known as sodium hydrogen carbonate. So sodium hydrogen carbonate, chemical name of this particular baking powder. So sodium hydrogen carbonate, if you write the chemical formula of sodium hydrogen carbonate, it is actually NaHCO3. So when you look at this particular chemical formula, you can clearly notice sodium is there, hydrogen is there, carbon is there, oxygen is there. So sodium, hydrogen, carbon, oxygen. So all these four elements are present in this particular baking powder. Coming to the D question, here they have given potassium sulfate. So if you write chemical formula of potassium sulfate, it is K2SO4. So here you can clearly see potassium is there, sulfur is there, oxygen is there. So the elements which are present in this particular compound are potassium, sulfur and oxygen. So all these three elements are present in this particular potassium sulfate. So coming to the sixth question, here they have given few set of compounds and you have to find out molar mass of that particular compounds which are given here. So what is the difference between molar mass and molecular mass? So here magnitude of both molar mass and molecular mass are same, but molar mass is having gram per mole as its SI unit and molecular mass will be having atomic mass unit as its unit to measure this particular molecular mass. But to understand how molar mass has gram per mole as its SI unit, you have to understand what you mean by mole. So to understand what you mean by mole, you should understand Avogadro's number. So all these concepts are there in your next chapter, and also these concepts are there in your higher classes as well. So there we will be discussing all these concepts. So as of now, if you want to calculate the magnitude of molar mass, you can calculate the individual atomic mass of the elements which are present in a particular compound, and you can add it up. So that can give you the molar mass of that particular compound. So the first compound which they have given in the sixth question is, that is in the A question they have given ethane, and they have also given the chemical formula of ethane, that is C2H2. Here you can see two carbon atoms are there and two hydrogen atoms are there. We know that the atomic mass unit of carbon is 12 and hydrogen is 1. Here two carbon atoms are there, so two carbon atoms will sum up to 24 and two hydrogen atom will be sum up to 2. So now again you should add this particular 24 and 2. So 24 plus 2 will be 26. So 26 AMU will be the molecular mass of this particular C2H2, or if you express this as molar mass, then 26 gram per mole is the answer for this particular C2H2. So the answer for A question will be 26 gram per mole, because here they have not asked molecular mass, they have asked molar mass. So the unit of molar mass is gram per mole. So the same atomic mass unit you can express it as gram per mole. So 26 gram per mole is the answer for this particular ethane molecule. Coming to the B question in this particular sixth question, here they have given sulfur molecule, that is S8 molecule. So the individual atomic mass unit of one sulfur atom is 32. So if you want to express this in molar mass, then 32 gram per mole is the molar mass of one sulfur atom, or 32 atomic mass unit is the atomic mass of one sulfur atom. So here 8 sulfur atoms are there. So you should multiply this 32 with 8. So when you multiply 32 with 8, it will be 8 2s are 16. So 1 carry, 8 3s are 24. So 24 plus 1 will be 25. So 256 gram per mole is the molar mass of this particular S8 molecule. So coming to the C question in the sixth question, there they have given P4 molecule. So P4 is actually made up of phosphorus. So one phosphorus atom has atomic mass as 31 AMU, or if you express this in molar mass, then it will be 31 gram per mole. So now if you want to calculate molar mass of P4, then you have to multiply this 31 with 4. So 4 into 31 gram per mole will give you, so 4 1s are 4, 4 3s are 12. So 124 gram per mole, so this is gram per mole, is the molar mass for P4 molecule. So coming to the D question in this particular sixth question, there they have given hydrochloric acid, that is HCl. So here one hydrogen atom is there and one chlorine atom is there. So atomic mass unit is of hydrogen is 1 AMU, or if you express this in molar mass, then it will be 1 gram per mole. And the mass, the molar mass of chlorine, or the atomic mass unit of chlorine is 35.45 AMU, or this can be expressed in molar mass as well. So that is 35.45 gram per mole. So now you can add these two. So 1 plus 35.45 will be equal to 36.45 gram per mole. So 36.45 gram per mole is the answer for this particular D question. So this is the molar mass of HCl molecule. Coming to the E question in this particular sixth question, there they have given HNO3 molecule. This is known as nitric acid. So here you have one hydrogen atom, one nitrogen atom, 3 oxygen atom. So atomic mass unit of hydrogen is 1 AMU, or if you write this in molar mass, then it will be 1 gram per mole. Similarly for nitrogen it is 14 gram per mole, and for oxygen it is 16 gram per mole. So now you can add all these three, but here oxygen you can see 3 atoms are there, so you should multiply 16 with 3 as well. So 1 plus nitrogen is 14 plus oxygen, there are 3 oxygen atoms, so 3 into 16 should be written in bracket. So now you can solve this. 1 plus 14 plus 3 into 16 is 48. So 48 plus 14 gives you 62. 62 plus 1 is 63. So 63 gram per mole is the answer for this particular E question. That is 63 gram per mole is the molar mass of nitric acid, that is HNO3. So this is all there in this particular video. I have explained all 6 questions which are there in this particular exercise of 3rd chapter in 9th standard science subject. So like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.